Okay, so I hope you did the exercises yourself. If you haven't, please do so now. Now I provide you with a quick solution of how to solve these tasks. The first task was simply to create a vector containing the numbers 2, 5, 2.4, and 11. And we can think of a name like solution vector 1. And then we can use the function C to concatenate the different elements, in this case 2, 5, 2.4, and 11. And that's basically it. So if we have a look at this vector down here, we see that it has the elements 2.5, 5.0, 2.4, 11.0. We also see that the 2 and the 5 were automatically transformed into integers and into doubles. We can verify this by using the function typeOf to check the type of the vector, which is in this case a double, which refers to the hierarchy of the different object types that we encountered before, because double is on a larger place on this hierarchy than integers, meaning that the overall vector always gets the type of the element which is highest on the hierarchy, in this case double. Doesn't matter whether there are 3 elements that are of type integer and 1 element that is of type double. In the end, even if it's only 1 element against many others, the element on the highest level of the hierarchy of object type determines the overall type of the atomic vector. And if we transform this vector here into the integer type, we can do so by using the function asInteger, and then just type the name of the original vector, and we actually see that now every single element of the vector has been transformed into an integer. And we also see the little bit counterintuitive behavior of the asInteger function when it comes to decimal numbers, because 2.4, it just cuts everything after the decimal point, so 2.4 is becoming 2. And then we come to the last question. Do you think you can create a vector containing the following elements? 2 with quotation marks, hello, 4.0, and true. So here the elements that we have. 2 is of type character. Hello is also of type character. 4.0 is of type double, and true is of type logical. So you might think that this is actually not possible, because I explained to you that the essential feature of atomic vectors is that they can only contain elements of the same type. But if we actually execute this operation, we see no error. And if we look at the result, we see that the vector now contains only characters, and all non-character vectors were automatically coerced into the character type. So we can verify this by using the function typeOf to see that this overall vector is a character. And again, here you see that those elements that score highest on the hierarchy of object types determine the type of the overall vector. And here we have 2 character objects. Character objects are highest on the hierarchy, so this is why the overall vector, simply without issuing a warning, is coerced into a vector of type character. That's very important to keep in mind in practice, because it's a common source of errors if objects are coerced automatically without a warning and without you taking note of it.